Somewhere in a server room that officially does not exist, a machine heard something it was never designed to hear. Not a star, not static, not the background noise of a dead universe doing what dead universes do. It heard a pattern, and patterns are the one thing that terrifies scientists more than silence, because silence can be explained, but a pattern demands an author. Imagine being told that the loneliest place in our solar system, a frozen moon locked in permanent twilight, orbiting a gas giant that could swallow 1,000 Earths, just stopped being lonely. Imagine being told that an artificial intelligence built only to sort noise from signal did its job a little too well. And imagine being told, quietly, off the record, that the people who found this are no longer answering questions. Not because they don't know the answer, but because they do. Let's talk about what may have happened out past Jupiter, in the ice, in the dark, in a place we were never supposed to be listening this closely. Here's the story, built as a what-if scenario grounded in real science, real missions, and real unanswered questions about Europa. Not a confirmed event, but the kind of thing that could very plausibly be sitting in a classified folder somewhere, waiting. Read that again. More water than our entire planet holds, sealed under a shell of ice somewhere between 15 and 25 kilometers thick, kept liquid by the relentless gravitational squeezing of Jupiter itself. That squeezing generates heat. That heat means chemistry. And chemistry, given enough time, has a habit of becoming something else. This is where the story usually stops. In most explainer videos and most textbooks. Interesting ocean. Interesting moon. Maybe life, maybe not. Who knows? Science will find out eventually. But here's where it gets worse, or better, depending on which way your spine wants to feel. Because in this scenario, it isn't just an ocean scientist we're watching. It's a signal. Not the kind of signal that arrives once and disappears, the kind that gets published, argued over, and forgotten within a news cycle. This is the kind of signal that keeps repeating, the kind that has structure, the kind that, when handed to a machine learning system trained purely to find compression patterns in noisy data, doesn't get dismissed as static. It gets flagged, highlighted, escalated. Think about what that means for a moment. An AI system doesn't have an imagination. It doesn't want to believe in aliens. It doesn't dream about first contact. It has one function: find the pattern, ignore the noise, report the anomaly. When a machine with no motive to lie, no career to protect, no reputation to lose, tells its handlers, "This is not random," that is a very different kind of moment than a human scientist making a bold claim on camera. Machines don't need attention. Machines don't need funding. And when a machine says something is deliberate, the silence that follows is not disinterest. It's the sound of people trying to figure out how to say it slowly to the right people in the right order. According to informed analysis of how these detection systems typically work, and how agencies have historically responded to anomalous signals, the process would look something like this. First, an automated system flags an irregularity. Then, a small internal team is assigned quietly to verify whether the anomaly is instrument error, cosmic background interference, or something structured. This is normal. This happens constantly across every observatory on Earth, for every strange blip that never makes headlines. 99.9% of these blips die in that verification stage. They are noise, they are dust, they are equipment hiccups. But every so often, something survives the filtering. Every so often, the noise refuses to behave like noise. And this is where everything changes, because a signal that survives verification does not get published. It gets escalated. It moves from a small research team to a slightly larger one, then to advisors, then to people whose names you have never heard, sitting in rooms that don't appear on any turned out to be wrong. Nobody wants to be the agency that stayed silent and turned out to be right, too. So the process becomes slow, careful, almost unbearably so from the outside looking in. Now here is the part that should genuinely unsettle you. In this scenario, the signal from Europa isn't just detected once. It's detected in a pattern that repeats, on a cycle tied to Europa's orbital position relative to Jupiter, meaning it behaves less like a natural phenomenon and more like something responding to its environment. Natural phenomena tend to be indifferent to timing. Radio bursts from pulsars, gravitational anomalies, background radiation. These things follow physics, not schedules built around a moon's orbital geometry. But when a signal's strength or clarity changes based on the angle between the moon, the planet, and the observing point, you start asking a very different kind of question. You start asking whether something down there is using the planet's magnetic field or its own orbital position, the way we use a mirror to catch sunlight and throw it somewhere specific. This is not chaos. This is strategy, or at minimum, the appearance of strategy. and that appearance alone is enough to change everything about how an institution behaves. Let's slow down and add the layer that usually gets lost in these stories. The actual science that makes an ocean moon like Europa disturbingly plausible as a candidate for something to hide within. NASA's Galileo mission, decades ago, detected variations in Europa's magnetic field that strongly implied a subsurface saltwater ocean, because saltwater conducts electricity and interacts with Jupiter's magnetosphere in a measurable way. This wasn't speculation. This was hard data, published, peer-reviewed, uncontroversial. The James Webb Space Telescope has since detected carbon dioxide and other chemical signatures on the surface that appear to originate from that internal ocean, meaning material is moving from below the ice to the surface. That means Europa isn't a static ice cube. It's a moon that breathes in its own slow geological way, cycling material between a hidden ocean and open space. Now stack that fact onto the next one. Europa's ocean floor, based on gravitational modeling, may sit directly on a rocky mantle, which means hydrothermal activity. The same kind of chemistry that created the earliest conditions for life on Earth around deep sea vents becomes not just possible, but likely. On our own planet, some of the earliest and strangest life forms didn't need sunlight. They needed heat, minerals, and time. Europa has heat from tidal flexing. It has minerals from mantle contact. And it has had roughly 4.5 billion years of time. Think about what that means. Not a hypothetical laboratory experiment. A real, sealed, undisturbed environment running the exact experiment scientists spend careers trying to simulate in a beaker. But here's where the scenario escalates past biology and into something far harder to sit with. Life is one thing, structure is another. A microbial ecosystem does not produce a repeating signal with mathematical regularity tied to orbital mechanics. Microbes don't triangulate. Microbes don't modulate frequency in response to gravitational positioning. If the pattern in this scenario holds whatever produced it, either evolved a level of complexity that dwarfs anything found in Earth's oceans, or it was never a product of blind evolution at all. And that distinction between life exists and something built this is the line between a fascinating discovery and a civilization-altering one. This is the point where most institutions, in this hypothetical, would begin behaving exactly the way silence-driven speculation online often describes, not because of cover-up for its own sake, but because of liability, geopolitics, and public panic management. Consider the practical reality. If a government-linked research body confirmed, even privately, that a structured signal originated from beneath Europa's ice, the first instinct would not be a press conference. It would be verification, replication, and containment of information until confidence reached a threshold high enough to survive global scrutiny. What most people are not seeing is that the scientific process and the public disclosure process are not the same process. Scientists can be enormously confident internally while remaining publicly silent for months or years, simply because we think is not the same as we know, and institutions live and die by that distinction. And here's where the story pulls in something even more uncomfortable: the role of the AI itself. In earlier decades, an anomaly like this would have been reviewed exclusively by human analysts, cross-referencing years of prior data, running statistical models by hand, taking months to reach conclusions. Today, machine learning systems trained on decades of astronomical noise can process the same volume of data in hours instead of years. That's not a minor technical upgrade. That's a fundamental shift in how quickly an institution can move from curious anomaly to confirmed pattern. The machine doesn't get tired. It doesn't need convincing. It doesn't second-guess itself out of fear of ridicule. It simply reports probability. And when the probability of natural explanation drops low enough, fast enough, the humans downstream of that report don't get the luxury of a slow, comfortable adjustment period. They get hit with certainty at machine speed and have to catch up emotionally and institutionally in a fraction of the time previous generations of scientists would have had. Think about what that does to the people inside that process. Not because they're hiding something sinister, but because they were handed, potentially, one of the most significant pieces of information in human history on a timeline that gave them no time to prepare a script for how to tell the rest of us. And this is where the phrase "scientists went silent" stops sounding like a conspiracy theory and starts sounding like a fairly predictable human response to being handed something too large to summarize in a soundbite. Now escalate the stakes further, because this is where geopolitics enters the story. Europa is not just a scientific target. It is one of the most fiercely contested destinations in the next era of space exploration, with multiple national space programs actively planning or executing missions toward the Jupiter system specifically because of its ocean and its potential for hosting life. NASA's Europa Clipper mission, launched in recent years, exists precisely to characterize that ice shell and subsurface ocean in unprecedented detail. using radar designed to see through kilometers of ice. The European Space Agency has its own Jupiter-bound mission examining the wider system of icy moons. China has signaled ambitions toward deep space exploration targets well beyond the Moon and Mars, when multiple nations are independently funding multi-billion-dollar missions toward the same small moon. That tells you something about how seriously the scientific establishment already takes Europa's potential, even before adding a mysterious signal to the equation. Here's where it gets worse. If, in this scenario, one nation's research team detected something first, the incentive structure is not cooperation, it's leverage. A discovery of structured signals from an ocean world would represent, potentially, the single most valuable piece of information a government could possess, not because of the signal's content necessarily, but because of what it proves about the universe, and who gets to be first to prove it. Nations that appeared indifferent to space exploration for decades have quietly ramped up deep space budgets in recent years, and while public justification always centers on resource extraction or scientific prestige, the underlying question in a scenario like this becomes obvious. What if prestige isn't the real motivator anymore? What if verification is? And this is where everything changes again, because verification requires more missions, more instruments, more time in orbit around Europa specifically, and that is exactly what's happening in the real world regardless of any hidden signal narrative. The Europa Clipper is expected to perform dozens of close flybys, using ice-penetrating radar, magnetometers, and thermal instruments to map the ocean beneath the ice with a level of detail no prior mission achieved. If a structured signal genuinely existed and needed confirmation, this is precisely the mission architecture you would build to get it. Not a single flashy announcement, but years of quiet, methodical technical verification, exactly the kind of process that looks like scientific caution to the public, and looks like confirmation in progress to anyone paying close attention to funding priorities and instrument specifications. Think about what that means for the timeline we're all currently living inside. If this scenario holds any water, so to speak, the true confirmation or denial of a structured Europa signal isn't a today problem. It's a next several years problem, tied directly to how long these missions take to gather sufficient data, process it, and clear internal review before any public statement could be justified. That's not a satisfying answer if you want drama tonight, but it is precisely the kind of frustrating, slow-burn timeline that would explain why scientists went silent instead of scientists announced. Because silence, in institutional science, usually means we don't have enough data to say anything responsible yet, far more often than it means we know and we're hiding it. But let's not let that calm you down too quickly, because here's the layer that keeps this story alive even under the most skeptical scrutiny. Historically, when anomalies of genuine scientific weight have emerged from unexpected radio bursts to unexplained astronomical objects, the pattern of institutional behavior has been remarkably consistent. Initial detection. Internal. Verification, often taking months. Careful, hedge-heavy public language using phrases like unexplained or requires further study, rather than definitive claims. And only much later, sometimes years later, does a fuller picture emerge through published papers, follow-up missions, or leaked internal communications. If a Europa signal scenario followed this same well-worn institutional pattern, we would expect exactly what we're seeing in the broader discourse right now. Increasing scientific interest in Europa specifically, increasing mission investment specifically targeting subsurface ocean characterization, and a conspicuous absence of any dismissive, case-closed statements from the agencies most invested in studying this exact moon. Here's where it gets worse one more time, because the deeper you dig into why Europa specifically, rather than any other icy moon in the solar system, the harder it becomes to treat this as random scientific curiosity. Saturn's moon Enceladus also has a subsurface ocean and even vents plumes of water directly into space, offering an easier, less invasive way to sample its chemistry. Yet, mission funding and attention toward Europa has consistently outpaced attention toward Enceladus in recent years, despite Enceladus being, in some ways, an easier target. What most people are not seeing is that this prioritization decision gets made by people with access to far more preliminary data than the public ever sees, and prioritization decisions like this are rarely, if ever, made on public information alone. Now bring the AI thread back into the center of the story, because this is the detail that changes the entire emotional register of what we're discussing. Machine learning systems used in modern astronomical data analysis are typically trained to detect anomalies, not to interpret meaning. An AI can tell you this pattern deviates from expected background, noise by a statistically significant margin. It cannot tell you this is a greeting, or this is a warning, or this is a language. That interpretive leap from anomaly to meaning still requires human judgment, human linguistics, human context. So even in the most dramatic version of this scenario, Where an AI system genuinely flagged something, structured coming from beneath Europa's ice, the idea of it being definitively translated runs ahead of what any current AI system is capable of doing. Translation implies comprehension of intent, of grammar, of symbolic meaning, none of which current machine learning architectures possess in isolation from a known language structure to map against. And this is exactly why scientists went silent becomes the more believable half of this story, even if AI translated the signal gets ahead of itself. Because the silence isn't necessarily about a completed translation revealing something terrifying. It's about the terrifying uncertainty of a structured anomaly that cannot yet be explained, translated, or dismissed, sitting in a scientific limbo that no one in a position of authority wants to speak about publicly until they have something more concrete than, we don't know, but it doesn't look random. Think about what it would feel like to be one of those researchers. Not a movie villain in a bunker, a person who spent a career studying magnetometer data and radar returns, suddenly staring at a pattern that keeps repeating in a way that shouldn't repeat, with no natural explanation, surviving 3 rounds of internal review. You wouldn't run to a microphone. You would go quiet, because the professional cost of being wrong about something this large is catastrophic. And the professional cost of staying cautiously silent is, at worst, mild criticism for excessive caution. Every incentive in that room points toward silence. Every incentive points toward waiting for the next mission, the next flyby, the next dataset, before saying anything that can't be walked back. This is where the story arrives at its most uncomfortable truth. The real story, based on everything currently observable in public mission planning, funding trends, and institutional behavior, may not be a single dramatic discovery hidden in a vault somewhere. It may be something slower and, in its own way, more unsettling. A scientific establishment that has quietly reprioritized its entire deep space strategy around one small ice-covered moon, funneling billions of dollars, years of mission planning, and its most advanced instruments toward answering a question it refuses to state out loud in plain language. Not because the answer is confirmed, but because the possibility alone has become too significant to ignore and too dangerous to discuss carelessly in public before the data is undeniable. So where does that leave us? Europa Clipper continues its journey, gathering data that won't be fully understood for years. Other nations continue quietly expanding their own deep space ambitions toward the same small moon, for reasons they describe publicly as scientific curiosity and describe privately, perhaps, in far more urgent terms. And somewhere in the gap between what the instruments are capturing and what the public is being told, a question sits unanswered, growing heavier with every flyby, every data packet, every quiet extension of a mission that was never supposed to take this long to explain in simple terms. Is there truly a structured signal beneath the ice of Europa? Is an artificial intelligence somewhere sorting through patterns too complex for the humans monitoring it to fully explain yet? Are the world's most advanced space agencies racing toward the same moon because of scientific curiosity, or because of something they've already glimpsed and can't yet prove? Nobody outside a very small circle knows for certain. And maybe that's the most honest ending this story can have, because the truth about Europa, whatever it turns out to be, is still down there, sealed under kilometers of ice, waiting for an instrument precise enough, patient enough, and brave enough to bring it back to the surface. When that moment comes, whenever it comes, the silence will finally break. The only question left is whether we'll be ready for what it says.